To random string generator, make a random string generator. You will need to start with a string containing all the letters in the alphabet. Var alphabet equals not booksies. To pick a random letter from this string, you can update the code we used for the random insult generator in Chapter 3 math.floor/math.randomalphabet.length. This will create a random index into the string. You can then use square brackets to get the character at that index. To create the random string, start with an empty string var random string equals. Then, create a while loop that will continually add new random letters to this string, as long as the string length is less than 6 or any length you choose. You could use the equals operator to add a new letter to the end of the string. After the loop has finished, log it to the console to see your creation. 3H4CK3RSP34K turn text into H4CK3RSP34K. A lot of people on the internet like to replace certain letters with numbers that look like those letters. Some numbers that look like letters are 4 for A, 3 for E, 1 for I, and 0 for O. Even though the numbers look more like capital letters, we'll be replacing the lowercase versions of those letters. To change normal text to H4CK3RSP34K, we'll need an input string and a new empty. To the output string. After the loop, log the output string to the console. If it works correctly, you should see it log J4B4SCR1PT14W3S0M3. In this chapter we'll build a hangman game. We'll learn how to use dialogues to make the game interactive and take input from someone playing the game. Hangman is a word guessing game. One player picks a secret word, and the other player tries to guess it. For example, if the word were teacher, the first player would write. The guessing player tries to guess the letters in the word. Each time they guess a letter correctly, the first player fills in the blanks for each occurrence of that letter. For example, if the guessing player guessed the letter E, the first player would fill in the ES in the word teacher like so. When the guessing player guesses a letter that isn't in the word, they lose a point and the first player draws part of a stick man for each wrong guess. If the first player completes the stick man before the guessing player guesses the word, the guessing player loses. In our version of Hangman, the JavaScript program will choose the word and the human player will guess letters. We won't be drawing the stick man, because we haven't yet learned how to draw in JavaScript. We'll learn how to do that in Chapter 13. To create this game, we have to have some way for the guessing player human to enter their choices. One way is to open a pop-up window which JavaScript calls a prompt that the player can type into. Click Cancel at the dialog, and you should see this. Hello null here. Null is printed as a string by console.log. Normally, null isn't a string, but since only strings can be printed to the console and you told JavaScript to print hello null, JavaScript turns the value null into the string null, so it can be printed. When JavaScript converts a value into another type, it's called coercion. Coercion is an example of JavaScript trying to be clever. There isn't any way to combine a string and null using the operator, so JavaScript does its best with the situation. In this case, it knows it needs two strings. The string version of null is null, which is why you see the string hello null. Printed. Confirm. Answer. For example, here we use confirm to ask the user if they like cats. See figure 7-2. If so, the variable likes cats is set to true. And we respond with you're a cool cat. If they don't like cats, likes cats is set to false. So we respond with yeah, that's fine. You're still cool. Var likes cats. Equals. Confirm. Do you like cats? If likes cats. Console. Log, you're a cool cat. Else. Console. Log, yeah, that's fine. You're still cool. Figure 7-2. A confirmed dialog. The answer to the confirm prompt is returned as a Boolean value. If the user clicks OK in the confirm dialog shown in figure 7-2, true is returned. If they click cancel, false is returned. With an OK button. For example, if you think that JavaScript is awesome, you might use this alert function. Alert, JavaScript is awesome. Figure 7-3 shows what this simple alert dialog would look like. Figure 7-3. An alert dialog. Alert dialogs just display a message and wait until the user clicks OK. Console.log. Tell the player something. Using alert means the player doesn't have to interrupt gameplay to open the console to see a status message. Second, calling alert, as well as prompt and confirm. Pauses the JavaScript interpreter until the user clicks OK or cancel, in the case of prompt and confirm. That means the player has time to read the alert. On the other hand, when you use console.log, the text is displayed immediately and the interpreter moves on to the next line in your program. Before we start writing the Hangman game, let's think about its structure. There are a few things we need our program to do. 1. Pick a random word. 2. Take the player's guess. 3. Quit the game if the player wants to. 4. Check that the player's guess is a valid letter. 5. Keep track of letters the player has guessed. 6. Show the player their progress. 7. Finish when the player has guessed the word. Apart from the first and last tasks, picking a word for the player to guess and finishing the game, these steps all need to happen multiple times. And we don't know how many times. It depends on how well the player guesses. When you need to do the same thing multiple times, you know you will need a loop. But this simple list of tasks doesn't really give us any idea of what needs to happen when. To get a better idea of the structure of the code, we can use pseudocode. It's a way of describing how a program will work that looks like a cross between written English and code. Pseudocode has loops and conditionals, but other than that, everything is just plain English. Let's look at a pseudocode version of our game to get an idea. Pick a random word. While the word has not been guessed, show the player their current progress. Get a guess from the player. If the player wants to quit the game, quit the game. Else, if the guess is not a single letter, tell the player to pick a single letter. Else, if the guess is in the word, update the player's progress with the guess. Congratulate the player on guessing the word. As you can see, none of this is real code, and no computer could understand it. But it gives us an idea of how our program will be structured, before we get to actually writing the code and having to deal with the messy details, like how we're going to pick a random word. Hangman game. This means filling in the letters that the player has guessed correctly and showing which letters in the secret word are still blank. How are we going to do this? We can actually keep track of the player's progress in a similar way to how traditional Hangman works. By keeping a collection of blank spaces and filling them in as the player guesses correct letters. In our game, we'll do this using an array of blanks for each letter in the word. We'll call this the answer array, and we'll fill it with the player's correct guesses as they're made. We'll represent each blank with the string. The answer array will start out as a group of these empty entries equal in number to the letters in the secret word. For example, if the secret word is fish, the array would look like this. If the player correctly guessed the letter I, we'd change the second blank to an I. Once the player guesses all the correct letters, the completed array would look like this. F, I, S, H. We'll also use a variable to keep track of the number of remaining letters the player has to guess. For every occurrence of a correctly guessed letter, this variable will decrease by 1. Once it hits 0, we know the player has won. While the word has not been guessed. In this loop we display the current state of the word being guessed beginning with all blanks, ask the player for a guess and make sure it's a valid, single letter guess. And update the answer array with the chosen letter, if that letter appears in the word. Almost all computer games are built around a loop of some kind, often with the same basic structure as the loop in our Hangman game. A game loop generally does the following. 1. Takes input from the player. 2. Updates the game state. 3. Displays the current state of the game to the player. Even games that are constantly changing follow this same kind of loop, they just do it really fast. In the case of our Hangman game, the program takes a guess from the player, updates the answer array if the guess is correct, and displays the new state of the answer array. Once the player guesses all letters in the word, we show the completed word and a congratulatory message telling them that they won. Now that we know the general structure of our game, we can start to go over how the code will look. The following sections will walk you through all the code in the game. After that, you will see the whole game code in one listing so you can type it up and play it yourself. Var words equals JavaScript. Monkey. Amazing. Pancake. Var word equals words. Math.floor math.random. Words. Length. We begin our game by creating an array of words JavaScript, monkey, amazing, and pancake to be used as the source of our secret word, and we save the array in the words variable. The words should be all lowercase. And we use math.random and math.floor to pick a random word from the array, as we did with the random insult generator in Chapter 3. Answer array of letters in the word. Var answer array equals. For var I equals 0, I. Length I. Answer array I equals. Var remaining letters equals word. Length. The for loop that creates a looping variable I that starts at 0 and goes up to but does not include word.length. Each time around the loop, we add a new element to answer array. At answer array I. When the loop finishes, answer array will be the same length as word. For example, if word is monkey, which has 6 letters, answer array will be 6 underscores. Finally, we create the variable remaining letters and set it to the length of the secret word. We'll use this variable to keep track of how many letters are left to be guessed. Every time the player guesses a correct letter, this value will be decrement reduced by 1 for each instance of that letter in the word. While remaining letters 0. / game code goes here. / show the player their progress. / take input from the player. / update answer array and remaining letters for every correct guess. We use a while loop, which will keep looping as long as remaining letters 0 remains true. The body of the loop will have to update remaining letters for every correct guess the player makes. Once the player has guessed all the letters, remaining letters will be 0 and the loop will end. The following sections explain the code that will make up the body of the game loop. Showing the players progress. The first thing we need to do inside the game loop is to show the player their current progress. Alert answer array. Join. We do that by joining the elements of answer array into a string, using the space character as the separator, and then using alert to show that string to the player. For example, let's say the word is monkey and the player has guessed M, O, and E so far. The answer array would look like this: M, O, E. And answer array.join would be MOE. The alert dialog would then look like figure 7 to 4. Figure 7 to 4. Showing the player's progress using alert. Handling the player's input. Add, prompt takes a guess from the player and saves it to the variable guess. One of 4 things will happen at this point. First, if the player clicks the cancel button, then guess will be null. We check for this condition at with it guess equals null. If this condition is true, we use break to exit the loop. Note you can use the break keyword in any loop to immediately stop looping, no matter where the program is in the loop or whether the while condition is currently true. The second and third possibilities are that the player enters either nothing or too many letters. If they enter nothing but click OK, guess will be the empty string. In this case, guess.length will be 0. If they enter anything more than 1 letter, guess.length will be greater than 1. Add, we use else if guess.length equals 1. To check for these conditions, ensuring that guess is exactly 1 letter. If it's not, we display an alert saying, please enter a single letter. The fourth possibility is that the player enters a valid guess of 1 letter. Then we have to update the game state with their guess using the else statement at, which I'll do in the next section. Updating the game state. Once the player has entered a valid guess, we must update the game's answer array according to the guess. To do that, we add the following code to the else statement. For var j equals 0, j. Length j. If word j equals guess, answer array oi equals guess, remaining letters dash. Add, we create a for loop with a new looping variable called j, which runs from 0 up to word.length. We're using j as the variable in this loop because we already used I in the previous for loop. We use this loop to step through each letter of word. For example, let's say word is pancake. The first time around this loop, when j is 0, word j will be p. The next time, word j will be a. Then n, c, a, k, and finally e. Add, we use if word j equals guess. To check whether the current letter we're looking at matches the player's guess. If it does, we use answer array oi equals guess to update the answer array with the current guess. For each letter in the word that matches guess, we update the answer array at the corresponding point. This works because the looping variable j can be used as an index for answer array just as it can be used as an index for word. As you can see in figure 7 to 5. Figure 7 to 5. The same index can be used for both word and answer array. For example, imagine we've just started playing the game and we reach the for loop at ets say word is pancake. Guess is a. An answer array currently looks like this. The first time around the for loop at j is 0, so word j is p. Oh, your guess is A. So we skip the if statement at because P equals A is false. The second time around, J is 1, so word J is A. This is equal to guess. So we enter the if part of the statement. T. Key line answer array Y equals guess. Sets the element at index 1 the second element of answer array to guess. So answer array now looks like this. A. The next two times around the loop, word J is N. And then C. Which don't match guess. H. However, when J reaches 4, word J is A. Again. We update answer array again, this time setting the element at index 4 the fifth element to guess. N. Our answer array looks like this. A. The remaining letters don't match A. So nothing happens the last two times around the loop. A. T. The end of this loop, answer array will be updated with all the occurrences of guess and word. For every correct guess, in addition to updating answer array, we also need to decrement remaining letters by 1. W. E. Do this at using remaining letters. Every time guess matches a letter in word, remaining letters decreases by 1. O. NCE. The player has guessed all the letters correctly, remaining letters will be 0. Remaining letters 0 are still letters to guess, the loop will keep looping. Once remaining letters reaches 0, we leave the loop. We end with the following code. Alert answer array. Showing. Alert good job. The answer was word. The first line uses alert to show the answer array one last time. The second line uses alert again to congratulate the winning player.